We are in the year 2017 and we are in Audi. It's a large car manufacturer, you know it, and you can imagine that between inventing a car and the time the car is available in the market, you take 3.5 years. And what happens in these 3.5 years? The car manufacturer is planning his production to the very detail to be efficient and to make and produce such an engine in a time so that you can still afford to drive it and to buy it, of course. And in this period, hundreds of people with different roles and skills contribute to build up this planning process. And it takes place for each new model of a car. And this is also the fact for any of the 20,000 changes just Audi takes on their existing models. So you can imagine this is a tedious work to do, and up till then, the people dealing with that had the problem that they had to work on 12 different, very complex IT systems to derive the data in order to perform their end-to-end processes. So we have been asked to come up with a new solution, and this is what we are going to present to you right now, finally. So we are speaking about a digital twin.
Yeah, that's right, Mr. Sykora, but what is a digital twin?
Simply said, digital twins we need to simulate things cheaper and less dangerous.
In reality.
To simulate the reality cheaper and less dangerous.
What is the reality here?
There is no reality. We live in a multiverse, well, at least as the future is concerned, because we have never accurate data to describe the reality. We have different data which generate different predictions, and every choice we may take will lead to a different future. So there are as many realities as plans imaginable.
So is the reality of German car producers a multiverse?
Of course, even a German car producer doesn't have fully accurate and consistent data to describe the status quo. Different people interpret the data differently, and there are different ideas about the future products. And of course, there are many different variants of serial products, means you can buy the car in so many variants as there are seconds since the beginning of this universe.
So what are the real challenges?
Well, the challenge for a planning of such products is that the innovation cycles become shorter, and people want to have more individual products. So this means if you want to be competitive, you have to plan fast and accurate to have a production which is cost efficient. And if you are in a huge corporation where you have different IT systems, where you have to coordinate different responsibilities of different people, and where do you have to have a system which keeps transparency so that you don't have to reinvent the wheel, I mean the plan for a production again and again, then these are the challenges which we are coping with.
And the task for us, for SABO Mobile IT?
Well, we had the task to develop a system to handle the end-to-end process across the data of several legacy systems. We had the task to develop a tool which communicates or allows the communication between different people to document their work. And, well, we are speaking of the largest car manufacturers, Volkswagen, in the world. So they have quite a lot of data. They have amount of users, and they needed a system which is performant, fast. Now, all this could only be accepted if it is user-friendly, if the people accept this software and if the software is able to help them and assist them. We have heard before about the challenges in the environment of a company introducing digitalization. This is one point. If the systems are friendly and assist the workers, they are accepted. But now, enough of the theory. Thomas, show us quickly what we have developed.
I will do
And
my
the
best.
task is, in my new car, I have invented a fancy new steering wheel, which I want to assemble in the cars I'm producing. And this steering wheel has now 6 bolts instead of 4, and has to be produced or assembled in a different way.
So hopefully you can see it here. Yeah, exactly. Thank you very much. Yeah, ladies and gentlemen, exactly. A new steering wheel into a production, so into a brownfield production. I have only a few minutes, so this will be a hell of a ride, so please fasten your seatbelts. I will try to guide you through the system very quickly. First thing, as a planner, what I need to do is to get an overview about the current production and the process, and find a place where currently the steering wheel is incorporated. So looking at the system, on the left side we have all the production plants connected to my organization. We support multiple production lines at each production plant, and entering the one, we see at a glance the main KPIs on the top regarding the complete production process, and the list of belt sections with KPIs for each and every belt section here. Steering wheel incorporated probably somewhere in the cockpit assembly. Again, on the top, the main KPIs, mainly the average workers utilization, the timing of the production, number of production cycles, number of workplaces, and number of workers. And in the list below, we would find the right cycle, this one, where the steering wheel is currently being assembled with a pretty fine utilization. We have a green light. Entering the detail of the working place, again for the planner, most important information at a glance on the top, and many lists of supportive information next to it. This is the list of all working steps for the steering wheel, and we are particularly interested into this one today. The new steering wheel comes with 6 bolts instead of 4, so in our simulation we will definitely need to switch that. So all information for the planner at a glance on one place, coming from different legacy system, one of the biggest value. Now, creating a planning project. As simple as that, simply click the button, create the project. I already did that before, so let's move to the planning part of the system. All of my planning projects here, but we use this for our presentation. On the very top, you can see a workflow. This is one example of the assist functionality of the system, so the planner always know where he is, what he has to do next, and so that
we can probably skip this.
Skip that.
And go to the where we see it, how we have a whole planning process in here.
Okay.
The system assists us to go through all the steps of the planning, but let us look. How does the production site look like? The digital twin aspect
Will do.
Evident.
Will do. So digitally, we have defined the new working steps and the working process. Now in the sandbox simulation, I can create as many plan variants as I want to. Let's create a new one, enter the system, and try to clock the new working step in. The view switches to a 2D layout of the complete production hall. Here again we could see the belt sections. Zooming to the proper place in the production allows me then to select the working place. All the same information I presented before are available here again. So what we do now is we clock the old one out simply by drag and dropping, and we clock the new one in.
Well, but the new one takes more time.
Yeah, sure. 6 bolts instead of 4 will take more time. Let's try it. this again an assist functionality for the planner. He can try out. At the bottom you see it does not fit anymore.
At the bottom there.
At the bottom there. It's red if you can't see it. But yeah, let's try to clock it here. And as you can see, it fits in. The utilization recalculated and the system created the specific tasks for this working step to be accomplished by the planner.
He needs the material, we need the tools.
Exactly. So let's gain some space on the cycle.
I see the shelf from on the right side.
These are the shelves. This would be a holder, a handling machine. This is the steering wheel in a large conveyor, and we confirm the timing of the production step for the simulation purposes. And one last step, I don't want to bother with you.
All right. Okay. So we see you have done all this. Now it looks like a sketch, like a schematic picture. Is it really the real data?
No sketch. So this is a CAD perfection in the browser. You can even measure the distances to your objects here. So we are really scaled to the reality.
Now we have seen it as a map. Wouldn't it be handy to see it also in 3D?
Of course it would be. Magic button allows you that. So switch the view to a 3D mode of the application. And let's have a look at the shelves, at the complete line.
Oh, I see. There is a lot of data. You are now, in fact, zooming and rotating at the same time. Can you really handle that amount of data of a large production site?
This is pretty small. We have production halls of 50,000 square meters running in the browser in a 3D mode, and you can still move freely. So our signature dish of this 3D layout.
And this would work also on a tablet when I are on site, so that you can check inside the plant. And the tablet, as I know, also allows you to see things in virtual reality, so that you can combine the variant against the reality. Now, if you would summarize, what have been the main success factors of this application, which is now applied by Volkswagen?
From the planner's point of view, I would say the main feature is that he has all the information from the legacy system in one place. From the technical perspective, it is a very performant and quick browser-based application, cloud-based application, so scalability and performance. And the third main feature is the user experience. It's custom-based for the needs of planners. It's an design award-winning application, and it serves its purpose.
All right. So this was an insight. This is one application. It is an example of what is possible if you take a hands-on approach and have a solution-oriented thinking rather than a complicated. And I believe there are a lot of other ideas which we can implement for the Industry 4.0. So let us discuss, let us meet. We have a booth outside. If you have questions right now, please post them. Thank you very much for your attention.
Thank you very much.